This is part 1 of our Chapter 3 practice test review. We'll go for 15 minutes because that is the maximum time limit on the screen recorder, and then we will finish it up in part 2. So let's start with number 1. I have the graph of the function y equals x squared minus 5x. It's located below. And the question asks us to find its vertex and its intercept. So intercepts, for one, we can see them on the graph. They certainly look like they're a 0 and a 5, but we can verify this using the quadratic formula or hoping that it factors. This does indeed factor. I can factor out an x, so I get x times the quantity x minus 5. And to find its intercepts, I set it equal to 0. And so x equals 0, or x minus 5 equals 0, and so this does indeed give you the 0 that it looks like it gives you on the graph. And then when you solve the right-handed expression, you have x equals 5, and we have our two intercepts. To find the vertex, we're going to first locate the axis of symmetry, which looks like it's going through right about here. And then after we find the axis of symmetry, we're going to plug that into our function and get out the other part of our turning point. So the formula for the axis of symmetry is a negative b over 2 times a. Here b is a negative 5, so a negative negative 5 is a positive 5 over 2 times a, and a is a 1. And I get out an axis of symmetry of 2.5, so that is the x coordinate for my vertex. Now I'm going to take my 2.5 and plug that in to the expression. So I get 2.5 squared minus 5 times 2.5. And I can use my calculator. 2.5 squared minus 5 times the 2.5 is a negative 6.25. That is going to be the y part of my turning point, and there's my vertex. So that's how you find intercepts and your turning point, given that it's in standard form. Find the domain and range of the function. I have x squared minus 8x plus 4. If we graph this in the calculator, we can get a pretty nice picture, and then we can use the graph to help us. Now we know that a parabola is a polynomial, and polynomials have domains that are all real numbers. But when you look at your graph that's going off our screen just a little bit, you can see if you walk along your x-axis, there's no number that you plug in that you can't get a value out. And you can look in the table as well. We know that the end behavior for our parabola is it's both as x goes to negative infinity as x goes to positive infinity, y is always going to be going to positive infinity. And so our domain is going to be the set of all x's such that x is a real number. Basically, it's from negative infinity to positive infinity. So either one of these is fine. However, our domain is restricted, which happens with your even degrees. I'm going to zoom out a little bit so that we can maybe see our turning point. And now if you're walking along the y-axis, you can see once you get to wherever this turning point is, if you keep heading down to negative infinity, you're not going to have any part of the graph on there. And so wherever this turning point is, that's the lowest y value that you can get out. So we can either find the vertex like we did in number 1, or we can say second calc and go to the minimum, pick a number a little to the left, pick a number a little to the right, give a guess, and we'll spit out our y value. Your smallest y value that you can have is a negative 12. So for my range, I have y such that the y is greater than or equal to a negative 12. Or I can list it as negative 12 with a bracket because that negative 12 is included to positive infinity. Again, either one of those is fine. Your even degree polynomials will have a restricted domain. Number 3, find the minimum value of the function 4x times the quantity x minus 4 plus a 20. Give your answer in the form f of a equals b. So once you find that minimum value, they don't want it in x, y. They want it as f of x is equal to y. So you plug in this x value and you get out that y value. What is that minimum? This is just a fancy way to say, where's the vertex? What is my turning point? So I'm going to come in here. I'll go ahead and distribute the 4x. So I have 4x squared minus 16x plus 20. I'm going to hit graph. I have a parabola. So my minimum is right about here. I think I could probably do zoom standard. And I will find the minimum the same way as I did before. Second calc, go to min. Pick a value that's a little bit to the left. I got to get back on the page here. Pick a value a little bit to the right. Take a guess. And my smallest value happens at 4, and that's when I'm going to plug in actually the negative, or it looks like a positive 2. So I plug in a 2 and I get out the 4. And so when f of 2 is calculated, you get out a 4. And this is the minimum value. This is where it happens. There are different ways to write the same thing. 4, solve by factoring. So we're going to have to set this guy equal to 0. 4x squared minus 2x. Let's subtract the 6 to the other side. I can factor 2 out so that I get 2x squared minus x minus 3. You could also factor this with the 4, the 2, and the 6, but if you take out the greatest common factor, have a little bit of an easier time breaking up this trinomial into linear factors. So I'm looking for factors of 3. Then when I subtract it, I get a 1. And of course, one of these guys is going to get multiplied by a 3. And so if I have a negative 3x and a positive 2x, when I combine those, I get a negative 1. My leading term is a 2x squared, and my last term is a negative 3. So it looks like we have a winner. Take each piece, set it equal to 0. Now 2 doesn't ever equal 0, so we don't need to worry about the greatest common factor. 2x minus 3 is equal to 0, or x plus 1 is equal to 0. Solve both, and you will get x equals either 3/2 or a negative 1. Number 5, solve this equation using the quadratic formula. So the quadratic formula is a negative b plus or minus the square root of b squared minus 4ac all over 2a. B, unfortunately, is a negative 0.25. So a negative is a positive, plus or minus this negative 0.25 squared minus 4 times a, which is a 1, times c, which is a negative 1.64. All over 2 times a, which is a 2. I'm going to use the calculator to help me figure out what my discriminant is. And so the negative 0.25 in parentheses squared minus 4 times a times c, which is a negative 1.64. That's what's underneath my radical, 6.6625. If I remember correctly. And it says round to the nearest hundredth, so I'm going to have to find the positive version. So 0.25 plus the square root of 6.6225 divided by 2 gives me, I want the hundredth, so 1.41. Now do it again with the subtraction, so 0.25 minus the square root of 6.6225. Divide that by 2, and I get a negative 1/6. And those are my two terrible answers. You can get this also by graphing it in your y equals and then using the intersect, or well, you could use intersect. 0 would be easier, but you'd have to run it twice. A diver jumps off a springboard, dives into a pool, shows the distance of the diver from the surface of water. So time equals 0. It starts up at the top, 40 feet. As time goes on, you obviously you're going to get closer and closer to the water. Based on the quadratic regression model, when are we going to enter the water? So when is the distance between you and the water 0? So I need to go into stat edit and get this data in. If you have data in there, highlight your list titles and hit clear and then enter. So 0, 0.5, 1, 1.5 to 2.5, 40, 50.2, 50.46, 51.1. I had quite the jump off the board. 43.5, 19.4. And now we're going to run QuadReg, which is under Stat, Calc, QuadReg. And if you want to quickly put this into your y equals without having to jot down all the numbers, you can say second L1, comma, second L2, comma, and here comes the long part, vars, over to y vars, enter for function, enter for y1. And now when you hit enter, you'll get the QuadReg, but it will very nicely go ahead and put all of it over there for you. So when you hit graph, you'll see it pop up. And so there it is. It looks like it's exactly out of 3. But what we'll do is use second calc and go to 0. And you got to pick a little bit to the left once I get back down onto the screen. Now I'm off the screen. And a little bit to the right, which looks like it's under, and take a guess, which won't be very good because of how it is. And it looks like a 2.89 round to the nearest tenth, so a 2.9. Or, if you wanted to, you could use your very long, rounded off QuadReg and use the quadratic formula. Either one will be fine. Sketch the graph quickly. We know we have a root at 1, -2, and a 3. So here's my -2. Here's the 1. I'm sorry, +3. I think I said -3. If I want to know my front behavior, he's an x cubed, which is positive. So I'm going to be heading up from left to right with split behavior. And then also, because all of these all have a multiplicity of 1, I know they're all going to shoot through. So I'm going to go something like through this, turn around, come back down through this, turn around, and then head back up till forever like that. And that's my terrible sketch of my graph. I'm just guessing on maxes and mins. If you wanted to know for sure, you can pick a value in between both of these roots and get an idea of where you max out. And we'll do the next part in part 2.